this is, you know that this is the application header. The application is a better name. Here we have we are using the for example HTTP, but we can use any type of protocol. After that, in the next step, we added another information to this data, and this is the network header. In each function, for each function, we need to add one header to the original data we are receiving. After that, in the for example data link layer, as you saw, we added two things. First, Ethernet header or data link header. Maybe you ask me why we need to add two part of information here. You will learn about this. And also data link, okay, trailer. That's it, data link trailer. Let me to write here. And this is the encapsulation process. Encapsulation means in each step we need to encapsulate the data we are receiving again with a new header, or in the layer 2 with the layer 2 header and also layer 2 trailer. This is the encapsulation we are doing. And you know that this packet, the first packet is the message. We call it message. When you are hearing about the message, means only the application header, the HTTP header, for example. This is a segment. Okay, segment means we added the transport header to the message, and after that, this is the packet or datagram. You know it. After that, this is the frame. Let me to call it frame. And we are sending the frame. You know that here we have physical layer. In physical layer, okay, the frame should be converted. This is the physical layer. This can be copper cable or fiber optic or air, for example. Finally, the frame should be converted to the bits, and we are sending the bits. And also in the destination, for example, in the server here, assume that this is the server here, we are doing the reverse function. First, we are receiving in the server, we are receiving this part of information. We call it the frame. Okay. After that, we in destination, the Ethernet protocol should read the data link header and also data link trailer. After that, it should de-encapsulate these two parts and give these parts to the for example, a destination systems IP protocol or network protocol. Network protocol should read the network header, okay, and after that it should de-encapsulate the packet and gives this part of information to the transport layer protocol. Transport layer protocol again should read the transport header and should give only the application header to the application layer, and this means that we are de-encapsulating the data we are receiving in the destination. In source, okay, when we are sending, okay, when we are sending traffic, we are encapsulating traffic. Encapsulation, this is the process of encapsulation. But when we are receiving, okay, the data or traffic, we are de-encapsulating, or the process that is occurring is de-encapsulation. Let me to show you with some picture this process. Look at this picture. This is the encapsulation process. As you can see, in application layer, we have this message. I want to download a web page, for example, from this address. This is HTTP GET message, okay? And then we are sending this HTTP GET message to the transport layer, for example, TCP. In TCP, we are adding some information. For example, sequence number or source port and destination port. You know that the maybe you hear that the destination port or port of the HTTP is TCP port 80, okay? If you don't know, it's not important, but here we are adding source port, destination port, or some other information to the original message. Look at here, this is the original message, the green part, and now we are adding this header. This is the header. Now we have a segment. Here, as you can see, we can see the datagram. In most cases, we are referring the datagram to this packet, or maybe in some ebooks or in some documents you can see the datagram is a segment. It's not important. In most cases we are using message, segment, packet, and frame. Okay, datagram is not so famous. And after that, here we have network layer, source IP, destination IP should be added to our data, and now we have a packet, and finally we need to add some information. But here we can see the Ethernet trailer, but we have Ethernet trailer, don't worry about that. And here we have message, again the header of layer 4 means the transport header, the header of layer 3, and finally here we have the Ethernet header, the layer 2 data link layer header. And now as you can see, the frame is created and we can send it to the physical layer. This is the process of encapsulation. In the destination we have the reverse direction of the process. This is another diagram. Look at here, application, transport, network, data link, and physical. In application, we have data or message. Then we are adding the TCP header. This is the segment, and then we are adding the IP header. This is the packet, and then we are adding the data link header and also data link trailer. This is data link trailer, and this is the data link header. And now we have a frame, and here, as you can see, we have the bits. Look at here. Let me write here. This is the data or message. You can say data or message. This is the segment. Okay. And after that, this is the segment, and then this is the packet, and finally we have the frame. This is the frame. Frame is ready for forwarding or sending into the for example physical, and we can convert the frames to the frames bits to the physical voltage, or maybe to the fiber optic pulses, and also to the for example waves in the air. In this picture, you can see the process of the encapsulation and also de-encapsulation or decapsulation. In encapsulation for OSI model, because in OSI we have the same process. Look at here, the data is receiving by application layer, and then the traffic should be sent to the presentation layer. After that, session layer. After that, transport, then network, then data link, and finally physical. As you can see here, in each layer we are adding one header to the original data application header, data presentation header, data session header, data transport header, data network header, data frame header, and also here we have one trailer. After that, the data should be converted to the bits and forwarded to the physical layer. And in physical layer, when we are receiving bits, first we need to convert these bits to the frame. This frame now is receiving by data link layer. Data link layer should read the frame header and also frame trailer, and after the encapsulation should give the another part of data, the packet, to the network layer. In network layer, again we are using the network header, and after that, after the encapsulation of this network header, we are sending the remaining segment to the transport header. In segment we have transport header. In the transport layer should read the transport header. After that, it should de-encapsulate the transport header and finally send the other data to the higher levels. You know that we learned about the interaction between the same layers in the sender system and receiving system. This is the same layer interaction. As you can see, we have also the adjacent layer interaction. And here, as you can see, we have the process of encapsulation, such as the TCP-IP in OSI, and also the encapsulation or decapsulation in OSI. In OSI, in each layer, we don't use a name. In most cases, we can say this is the layer 7 PDU. Look at here. This is the layer 7 PDU. What is the PDU? PDU is the abbreviation of the protocol data unit. Let me write here. PDU is the abbreviation of the protocol data unit, and this is the L7 PDU means the product of the layer 7, and this is the product of layer 6 PDU, and this is the product of layer 5. For example, in OSI, don't worry about the detail of session and presentation. It's not important for us because we don't use the OSI in today's networks. We are using only TCP-IP. After that, this is the layer 4 PDU, the product of the layer 4, and this is the layer 3 PDU, and finally we have the layer 2 PDU. Look at here. This is the layer 2 PDU, and finally, as you can see, we are converting the layer 2 PDU, or in TCP/IP we call it the frame, to the bits. Also, let me to give you another picture. Look at here. This is the process of OSI encapsulation, and also here you can see the PDUs. As you can see in this picture, again we have OSI model, and data first in the application layer should be converted to the, for example, layer 7 PDU after adding the header, then layer 6 PDU, then layer 5 PDU, layer 4 PDU, layer 3 PDU, and finally layer 2 PDU. In layer 2 PDU, as you can see here, we have header and also the trailer. This is the process of OSI encapsulation, and also, as you can see here, we can see the PDUs. In the next video, I will talk about the Ethernet header and also Ethernet trailer. Actually, in the next video, I'm going to talk about the Ethernet fundamentals and some of the detailed information about the Ethernet. In each video, we will learn one of the topics we mentioned before. You know that if we want to be a master in the network, or in the CCNA, we need to learn everything step by step. Until now, we learned about the TCP-IP fundamentals and also some of the important terminology in TCP-IP. Now we can understand the process of the encapsulation or the encapsulation. We are understanding some terms such as the same layer interaction or adjacent layer interaction, and after that we can understand briefly function of the application layer, function of the transport layer, network layer, and also data link layer. In the next video, I'm going to give you more information about the layer 2, okay, Ethernet header, because Ethernet is one of the most important protocols that we are using. You know that we in this course we should learn about the LAN and WAN, okay, about the LAN, and in these days also the WAN. Ethernet, one of the most famous and most useful protocols, okay. Because of that, we will talk about the Ethernet and we will learn about the Ethernet fundamentals in the next video. But for now, it's a good practice, it's a good job for reviewing that for all of the topics that I mentioned in this video. Don't forget, if you want to be a master in network engineering, after each video you need to review the topics. Maybe also you need to take a note from the topics, or maybe you need to review the previous videos also, okay. It's okay. The time is not important for you. Don't forget, the time is not important, but the quality is important. You need to carefully study, okay, carefully learn, but don't worry about the details. Maybe in some of these videos you encounter with some for example problem. It's okay, because this is the start of the way of learning. You need to write all of your problems step by step. You will learn about them, maybe in this course or maybe in the next course, for example CCNP, but you will learn, okay. Let me to say that if you come with me step by step in each video and also practicing all of the scenarios I will give you, okay, you will be a master in CCNA. You can easily pass the CCNA exam or interviews about the CCNA. Very good. Please come with me to the next video. After reviewing this video, we will talk about the fundamentals of the Ethernet LANs.